So for page 15, let's measure the magnitude of each vector. Okay. Now you may have something slightly different than mine, but I'm going to go with my measurement. If you have different measurement, you can use your measurement. All right. So here, let's say vector A looks like 2.2 centimeters in the positive x direction. All right. So here, I'm going to write down 2.2 centimeters in x hat. And if I were to represent my vector A in two-dimensional plane in a Cartesian form or the component form, it should be 2.2 x hat plus 0 y hat centimeters as my vector A. Then for vector B, if I were to measure this, it looks like slightly more than 1.5. Definitely less than 1.6. I'm just going to write down 1.55 just so. All right, 1.55-ish. I'm going to write down 1.55. So 1.55 centimeters y hat. And if I were to represent that vector B in two-dimensional plane in a component form, it should be 0 x hat plus 1.55 y hat centimeters. Okay? And then for vector C, I have, let's see, it looks like 5.4 in the negative x direction. So negative 5.4 centimeters x hat. So if I were to represent my C vector in two-dimensional plane, it would be negative 5.4 centimeters x hat plus 0 y hat. Okay? So if I were to draw these vectors out, let's see what they would look like. Okay? So let's draw the A vector first because we're doing, take a look at this. This is important. My resultant vector is equal to A minus B plus C. So A minus B plus C. Okay? So it's not just straight out A plus B plus C. So let's start out with my A vector. Okay, starting from the origin, I'm going to go 2.2 centimeters in the positive x direction. So here, 2.2 centimeters in the positive x direction. All right, so that's my vector A. Okay, so here's my vector A. Minus B. So I'm adding negative B vector. So since my vector B is pointing in the positive y direction, since I'm adding negative B, it's going to be going down. So if I were to line up my ruler so that the reference line on my ruler is parallel with my y-axis and draw 1.55 centimeters along negative y direction, and that would be my vector negative b. So I added my negative b vector onto my A. Then I'm going to add my vector c, which is 5.4 centimeters in the negative x direction. And again, I'm lining up my horizontal axis with my reference line on my ruler, okay? And if I were to draw this correctly, it's gonna look like 5.4 centimeters. That looks about right, 5.4 centimeters. And that is my vector C. So my resultant vector would be from the origin to the tip of my last vector that I'm adding, which is vector C, and it looks like 5.5, but a little more than 5.5, but definitely less than 5.6, and looks like it's splitting the half between 5.5 and 5.6. So I'm going to say 5.55 as my resultant vector's magnitude. Okay, so here my R vector is the magnitude of my R vector looks like 3.55, right? 3.55. Now, of course, this is measured, okay? So these are measured. And let's measure the angle for this. And when I measure the angle for this, I will put my 0 degrees in the positive x direction and measure the angle counterclockwise. So this is actually theta right here, this whole thing. This is your theta r, okay? So your theta r, when I measure this as accurately as possible, it looks like, well, let's see. I get 206 or 20. Yeah, I see 206 as my 206. All right, it's like right on the dot, 206 on the dot. All right, 206 on the dot. So my theta is equal to 206 degrees on the dot. All right, so these are the measured values. So let's see how they work out if I were to calculate it out. All right, so since my first vector is A, and that is 2.2 x hat and 0 y hat. Now my second vector is negative B. So whatever I have for B, I'm going to have to negative it, right? So it's going to be 0 x hat, because negative 0 is still 0. And then this will be, instead of positive 1.55, I'm going to make it negative 1.55 y hat. And my C vector is negative 5.4. Charlie, you have a question?
I'm just wondering why is the C vector drawn going towards the left instead of the right? Because should it, if it's going towards the left, shouldn't it be negative? For the one we draw.
Yeah, my C vector is negative, negative 5.4.
For the one we draw, like it says vector r equals a positive a minus b plus c, and the c should be positive. Why is it going towards the left?
Because my C value is already negative.
Oh, okay. Yep, got it.
Got it? Okay.
Yep.
Because it is already negative. That is my C vector. Right? Good. Any other questions? All right. Good. All right. Then, where was I? Oh, here I have 0 y hat for my vector c. So when I add all the x's up, I will have rx, x hat. And then here, when I add all the y's up, I got ry, y hat. So let's add these up, and I get something like negative 3.2, right, centimeters x hat for my resultant. And for my y, I get negative 1.55 centimeters in the y direction. So this is my Cartesian form already. So this is my Cartesian form. But let's take one step further and go for polar form. All right. So my r is equal to square root of, all right, 3.2 squared plus 1.55 squared. And when I find the magnitude of this calculated one is 3.56 centimeters, which is pretty darn close to what we measured over there, 3.55, right? It came as close as like,
Why is R negative 1.55y? Isn't it? Why wouldn't it be rising?
because we are subtracting the b vector.
Oh, okay, yeah.
So we're adding the negative b. Is that okay?
Yeah.
Okay. Amanda, you have a question? Your mic's not working, Amanda. So if you have a question, you can, since your mic's not working, you want to type on the chat. So maybe I could share that with the rest of the class. All right. If your mic's not working, yeah, chat. Like, so I can actually read your questions to the rest of the class. Amanda's question is, I don't have a question. All right, that works. All right. So this is the magnitude of my resultant vector r. All right. So if I were to look at this here, and let's say I draw a grid line, I guess, right? So if we were to draw a grid line, and then let's say I try to make replicate my vector r on side here, right? So if I were to draw my vector r on the side, it should be, about 3.55 centimeters long. Now this doesn't have to be exactly like, and it should be 206. So like 206 would be like around here somewhere, right? 206. So like around here somewhere. So if I'm drawing my vector r, okay, now I'm not drawing it exact, okay. Oh, well, look at that. Look, this is parallel with my vector r down here, so I could actually draw it pretty close to the original vector that I should be going for my result. All right, so here, so here's, let's say this is my vector r, okay. Then this would be my r, y, okay. Here's my ry, and then here's my rx, okay. So this angle here is actually my angle beta, and this angle here is actually my angle theta, okay. So let's take a look at how we can calculate this angle beta to calculate my angle theta. All right. So to calculate beta, this is a right triangle. So beta is equal to tan inverse of, right, ry over rx. So my beta is equal to tan inverse of negative 1.55 over negative 3.2. And if you calculate that out, my beta comes out to something like 25.8 degrees, which is pretty darn good, actually, when you think about it, because since your theta r is in third quadrant, it should be 180 plus your absolute value of your beta. Therefore, your theta r comes out to 180 plus 25.8 degrees, which is 205.8 degrees. So that's pretty darn close to what we measured. And, well, I mean, this usually goes a lot wrong than this, because you have to really draw this thing precisely to get the same values. But our drawing looks pretty good here, right? So now you can represent your r vector in a polar system as 3.56 centimeters, comma, theta is equal to 205.8 degrees. So now you have both Cartesian and polar representation of my resultant vector. All right. Anyone have any questions so far? So that's pretty close. Look how close that is. I mean, that's really, I mean, that's drawn pretty cool. All right. I'm awesome. Anyway. All right. No questions? All right, then. We'll move on to the next page. Okay. We'll move on to the next page. Well, this looks a little bit more challenging. These vectors are not on the axis here, huh? They look like they're all over the place. So here's my vector A. Here's my vector B. Here's my vector C. And here's the resultant now. Now you have to be really careful with measuring these things out. All right. Now, if you don't have a protractor, it's going to be hard to do this. But for now, what I'm going to do is I'm going to do my best to show you how it should be done. So this will be a good example to go by. All right. So make sure you get your own protractor. If you don't have a protractor right now, or if you cannot get one, I would urge you to go to Google and type in protractor, and then go to the image and print out a small looking protractor. Make it a small, about this size, and then use that image. Hopefully that can save you from going out and buying one. All right. So let's measure out the A vector, the magnitude of the A vector first. So here we go. Of course, they want us to measure it in centimeters. So using a ruler and protractor, write each vector in polar form. So let's do that. So here, when I use my ruler to measure out the magnitude of my A vector looks like it is 3.1 centimeters. Okay, 3.1 centimeters. And let's write that down, 3.1 centimeters. And then, what about the angle? So this is my angle theta right here, right? Theta A. And if we were to measure that angle, where your positive x-axis is the 0 degrees, and then you have to measure it counterclockwise. All right, so if we were to do that, it looks like 141. All right, it looks like 141 on the dot. All right, so 141. So 141 degrees is what I get for theta A. All right. Now let's take a look at B vector. And the B vector, when I measure the magnitude of this, it looks like I don't know, what do you say? 6.3? I see 6.3. Okay, I see 6.3. 6.3 centimeters. And let's measure this angle theta B. Okay, so here, again, I put my 0 degrees in the positive x direction. And when I place this right at the grid line, so that the dotted grid line, oh, there you go, right? And that looks like 23 degrees on the dot. All right, 23 degrees. So I'm going to write that down, 23 degrees. So I hope you can replicate that as well on your side. All right. Now let's take a look at vector C. Vector C looks like I see vector C to be like 3.9. All right. I see vector C to be like 3.9 centimeters. All right, that's pretty close to 3.9. All right. So 3.9 centimeters. Now let's measure the angle theta. Now theta is measured from here all the way around this way for your theta C, okay? So if we were to place this, again, horizontally with matching up, all right? And then if I were to make it a little bit longer here, it looks like around 322, 322. Yeah, around 322, 321 and a half. I'm just going to go with 322 for now, because this looks like it's slightly off. I'm going to go with 322-ish. All right, 322. So if you go with 322, that looks about. Yeah, 322. All right, so 322. Now let's measure the theta and the magnitude of my resultant. So here my resultant, I get, let's see, 6. I get like 6.8 maybe. All right, I don't know if you guys can see that. I see 6.8. I mean, if you start from here, I guess it got slightly less than 6.8. But I see 6.8 to be more. So I'm going to write down 6.8 centimeters. Okay. And what about the angle? The angle for my resultant theta R is, let's see, it looks like it's splitting between 16 and 18, so 17. I'm going to say 17. All right, I'm going to say 17 degrees. Yeah, 17 degrees is what I get for my angle theta r. Okay? So, here's what you need to do. I need you to break up these A vector, B vector, C vector, and R vector. I need you to break them up into their components. So for example, here, this will be your AY, right? And then this will be your AX. And then this would be your, I guess, it's B, BX, right? This will be your BX. And then this will be your BY, okay? BY, okay? So if you can find the AX, AY, BX, BY, CX, CY, etc., find their components for each of my vectors right here, and we'll go from there. All right, so here is my CY, and this will be my CX. Right, CX. So let's find these components. I'll give you, I don't know, 4 minutes, maybe 6 minutes. All right, so let's see if you can do that. I'll pause the recording. So let's start with vector A, and let's find the components of AX and AY. Okay, so I will start with AX. So AX, since it is the adjacent to my angle, right, I can say AX is A cosine of my theta A. That will automatically give me the proper sign, right? So my AX is equal to 3.1 times cosine of 141. So my AX comes out to, looks like negative 2.41 centimeters. Okay? And then AY is equal to a sine of theta A. Therefore, my AY is equal to, let's box that off, 3.1 times sine of 141. And my AY is equal to 1.95 centimeters. Okay. Now let's take a look at BX and BY. So here, my BX is equal to B cosine of theta B, and my BX then is equal to 6.3 times cosine of 23 degrees. So my BX, I get 5.8 centimeters as my BX. My BY is equal to B times sine of theta B, and my BY then is equal to 6.3 times the sine of 23 degrees. So my BY is equal to 2.46 centimeters. All right. Now let's take a look at CX and CY. So CX is equal to C times cosine of theta C. So my CX is equal to 3.9 times cosine of 322 degrees. So CX is equal to, I get 3.07 centimeters as my CX. And then for CY is C times sine of theta C. So CY is equal to 3.9 times sine of 322. So my CY comes out to, I believe, negative 2.40 centimeters. Now, as far as RX and RY is concerned, I mean, you don't really have to do it, but let's do it anyway. Right? So here, your RX is equal to R times cosine of theta R. So your RX is equal to 6.8 times cosine of 17 degrees. And your RX, I believe you get something like, what do you get? Let's see, 6.8 cosine of 17 degrees. I get 6.50, okay, centimeters. And your RY is equal to R sine of theta R. So your RY is equal to 6.8 times sine of 17 degrees. And your RY is equal to 1.99, okay, centimeters. All right, so that's all fine and dandy now. So, but we're going to utilize these three vectors components and put it in here so that we can actually calculate what it should be like when we calculate them out instead of measuring them out graphically. So for A vector, we have 3.1 cosine of 141 for X. So it comes out to negative 2.41 X hat and 1.95 Y hat. Then for my B vector, I have 5.80 X hat and 2.46 Y hat. And then for vector C, I have 3.07 X hat minus 2.40 Y hat. So when I add all the X's, I should get my RX, right? And when I add all my Y's, I should get my RY. So when I add all the X's, what do I get? I get 6.46 centimeters in the X direction. And for Y direction, I get 2.01 centimeters in the Y. So this right here is your Cartesian form of your resultant vector. But let's see what happens if you were to find the magnitude of that calculation. That is square root of, right, 6.46 squared plus 2.01 squared. And if you work that out, I think you get something like 6.77 centimeters, which looks very close to 6.8, right? That looks very close to 6.8. And the theta R is your beta R, and your beta R, your theta R are the same because it's in first quadrant. So you do tan inverse of RY x, and that is tan inverse of, right, 2.01 over 6.46, and that comes out to 17.3 degrees, which is again very close to what we measured. So they worked out okay. All right. So it worked out okay. Any questions? All right. Yes, Charlie?
Yeah, so for the, let's see. Yeah, for B, the vector B values, I did the sine and cosine wrong. It's like, I did it opposite. I did it for cosine for y and sine for bx. I don't know why. Can you explain that part again?
Yeah, I don't know why I did that either. Well, here's B.
Right.
So this is in first quadrant right here, right?
Mm-hmm.
So if this is the angle theta, this is the adjacent, which is the BX. I just drew it here so it doesn't make it look too crazy here, you know? So if I drew that down here, the BX here, and then drew the BY here, it'd be the same thing. So the BX is the adjacent to my angle here, theta B. So it is, you got that? 6.3 times cosine of this angle 23 degrees.
But let's say if you, can you use the same formula for
Say it louder, I cannot hear you. What?
can you use the same formula for the lines you drew instead of like from the line? Can you do it above the line as well? Above the
Yeah, but then this angle here would not be 23 degrees, right?
line.
This would this would be 67 degrees. So if you
Next time I should just change the angle to the one that's inside instead of
here,
so I did. So mine was I did the same as how you drew on the paper.
okay,
So should I use an angle that's supplementary to?
not supplementary. You want to use complementary angle here.
Okay. Yeah, I got it.
Okay?
Thank you.
Yeah, sure. Any other questions? Alrighty then. Let's take one step further. Let's take one step further. And using this information right here, just using these information here, let's add vectors again, just algebraically, right? Algebraically. Here, let's say my R vector is equal to, ready? 2A minus 3B plus 1/2 C. Let's do this algebraically without even using rulers and protractors. I would like you to add these three 2A vector minus 3B vector plus 1/2 C vector algebraically. Okay? I'll give you a little hint. The hint is I would write down 2A vector and then write down negative 3B vector and then write down 1/2 C vector and then that will be your R vector. All right? I'll give you about 4 minutes. See if you can do this. Pause the recording. All right, so anybody have answers? Good. Come on. Anybody have any answers? All right. Let's take a look at 2a. This vector is just twice as much as a, which means this will have twice as much in the x direction, so it'd be negative 4.82 x hat. And this will be 3.90 y hat. Then you have negative 3b. Now, if you have negative 3b, that is... Oh. Sorry. All right, thank you. So, then you have negative 3b. You have 3 times the length as your x and y, but in the negative direction. So, my x component for my b vector will be negative 3 times 5.80, or negative 17.4 x hat, and negative 7.38 y hat. And for C, it will be half as Cx and half as much as Cy. So for Cx, it will be 1.535 x hat and negative 1.20 y hat. So everybody okay with that so far? Come on, give me some feedback. Yeah?
Yes.
Great. So when I add all the x's up, just like I did before, I get my resultant x. And when I do that, I believe I get something like negative 20.685 x hat for my Rx, and negative 4.68 y hat. So this would be my Cartesian form of my, right? Of my resultant vector, or component form, the same things, right? Cartesian form or component form, right? Now to give a polar form. Well, this looks like it's in negative x, negative y, so it looks like it's in third quadrant, okay? So if I were to, like, sketch this thing out roughly just to visualize, where that would be, it looks like it's going to be somewhere in third quadrant, with the negative 20 in the x direction and only negative 4.6 in the y direction. So this is your resultant vector right here. So this angle right here is your beta. So this here is your theta resultant. So utilizing this angle here, if we could figure this angle out, we could definitely figure out this theta. Well, let's do the magnitude of r first. So to figure out the magnitude of r, all we have to do is find the square root of, right, 20.685 squared plus 4.68 squared, okay? And if you do that, your resultant vector magnitude comes out, I believe, 21.21 centimeters. So that's the resultant vector's magnitude. Now to calculate beta, which is the reference angle. The beta is again tan inverse of ry over rx. So tan inverse of ry, which is negative 4.68, over rx, which is negative 20.685, and your beta comes out to 12.75 degrees. So your theta, because it is in third quadrant, it is 180 plus the absolute value of your beta. Therefore, it is 180 plus 12.75 degrees, which comes out to 192.75 degrees. Now I have both ingredients for my R, which is 21.21 centimeters, comma, theta is equal to 192.75 degrees as my polar form. Or the magnitude and direction form. Right? So are we okay with that? All right. So, any questions before we start the homework answer? All right, I'll pause the recording. So this is page 10, homework page. This is page 11. This is page 12. And this is page 13. So if you want to pause the button while you're seeing this live, then you can do that at the video. All right, so